All right, cool. Hey guys, Mr. Donahue again. I actually just finished the other video and doing this one now. 4.3, it's about acid and base reactions. So let's take a look at those problems that I assigned you. All right, so number 11, which one of the following is a weak acid? This you kind of just got to memorize, figure out which one's the weak acid. If you're red, you got it, that's it. HF, hydrofluoric acid, is a weak acid. Commit it to memory. Done. 12. Which of the following is diprotic? Break that down. Di means two. Protic is talking about protons. And what's a proton? Well, proton is the same thing as an H+. So it's saying which one of these things has an H+. You don't believe me that a proton is just an H+? Well, what's the mass of hydrogen? It's atomic number 1, mass of 1. That means it's got 1 proton. It's got 0 neutrons. All right. And it's got 1 electron when it's neutral. You get rid of that electron, you're left with just a proton, which is H+. There, I proved it. Get out of me. All right, so we got to figure out, well, what is nitric acid? I gave you guys the little trick. If it ends in 8, it's going to become ic acid. And if it ends in ite, right? If you had sulfite, it would end in us. It'd be sulfus acid. All right, so we got nitric acid. Well, what is that? Nitric, that must have been nitrate. So I know it's HNO3. That's only one H. Chloric acid, that must have been chlorate, which is ClO3. Here, I'll write down here. A would have been HNO3. B would have been HClO3 because ClO3 is -1. H is +1. C, phosphoric acid. Well, it must have been phosphate. And in ic, so phosphoric acid must have been H with a PO4, which is a -3. So the formula will be H3PO4. That's triprotic, right? It's got all that, 3 hydrogens. We take a look at dihydrofluoric acid. Well, that's HF. And then E, sulfuric acid. Well, that must have been sulfate, which is SO4 -2. So it must have had 2 H pluses, right? So choice E. All right. 13. Which of the following solutions will have the greatest concentration of hydroxide ions? So hydroxide ions are those OH minuses. So we got to figure out those formulas again. A, well, if it was rubidium hydroxide, I got to look up what the charge of rubidium is. It's +3, so I know it's going to be RuOH3. B would have been magnesium hydroxide, MgOH2, because Mg is +2. C, ammonia, which is NH3. Not going to give us many hydroxides from the formula itself. Beryllium hydroxide, Be, which is a +2, so it's going to be OH2, because each OH -1. And then E, hydrochloric acid, HCl. Now, this problem I'm not a huge fan of because I think it was too easy, because you could have gotten the right answer doing it the wrong way. You could have been like, hey, this is 0.30 molar, so that's got to give us the greatest concentration. It works out that it does, but if that's as far as you thought, then that's not good. Because what you got to do is figure out, well, how many hydroxide ions do I get from each formula? So if it was 0.3 molar of this molecule, then it would go to give you 0.9 molar OH minuses. Right? Now we take a look at B. Since we get 2 OH minuses and it was 0.100 originally, you get 0.200, which is not as much as 0.9. Find no numbers and which one's greater than the other one. You can do that for all of them. You're still going to end up A is going to be the most. So I hope you got that right for the right reasons, not for the wrong reasons. All right. We'll take a look. 14 says a neutralization reaction between an acid and a metal hydroxide produces, well, we always get, this is another one, acid plus base, because the metal hydroxide is a base, will always give you water into salt. That's it. All right, we look at 15. The spectator ion. Remember, spectator is somebody who just watches, isn't involved, but watches it. So spectator ion isn't involved in a reaction. It just kind of is there at the beginning and at the end. Between aqueous hydrochloric acid and aqueous ammonia. So I got hydrochloric acid and ammonia, which is going to give me what? Well, I know ammonia is a base. It's going to take up the H+. So I know I'm going to end up with NH4 plus and Cl minus. All right, well, we want the spectator ion. Well, if HCl is aqueous, we know it's a strong acid. It's really an H+ and a Cl minus. So what changed? Well, I can tell you this chlorine didn't change. It was a Cl minus and it ended up as a Cl minus. So we know that's got to be it. If we take a look at hydrogen, it ended up bonding, covalently bonding to NH3 to give us NH4. And the NH3 was also involved. You know, it changed. So it's not a spectator ion. Oh, snap. That's 4.3. We're done with 4.3. Hope you found it helpful. You know, bring some questions. And I'll catch you on the flip side.